Hello friends, welcome back. In this video, we are going to cover figure it out section for a square and a cube chapter. It is on page number 10 and 11 on your textbook. So there are total 9 questions in this figure it out section. Let's solve this. The first question is, which of the following numbers are not perfect square? Okay, so make sure you don't miss this not word. We have to find the number which is not the perfect square. To solve this, we are going to recall the two rules which you have studied before. So let's look at those rules and then solve this question. Okay, so the first rule is the perfect square can end with 0, 1, 4, 5, 6 or 9. And the second rule is a number which is ending with 2, 3, 7 or 8 cannot be the perfect square. So let's use the rule number 2. So any number which is ending with 2, 3, 7 or 8. So let's see what number is ending with 2, 3, 7 or 8. So the first number is ending with 2. The second number is ending with 8. The third number is ending with 7. The fourth number is ending with 9. So the first three options 2032, 2048, 1027. The last digit falls under the second rule. What it means is these three numbers cannot be the perfect square, whereas the fourth number 1089, it falls under the first rule. The perfect square can end with 0, 1, 4, 5, 6 or 9. So this can be the perfect square. So answer of this first question is option number 1, option number 2 and option number 3. Okay, so the answer is 1, 2 and 3. Second question, which one among 64 square, 108 square, 292 square and 36 square has last digit as 4? So we need to see the unit digit should be 4 of these squares. So we don't need to find the square of all these numbers, right? We don't need to do 64 into 64, 108 into 108 and so on. So what we need to do is we just need to do the square of the unit digit of these numbers. So in this case, square of 4, square of 8, square of 2 and square of 6 and compare. Okay, as I said, we need to do the square of the unit digit. So square of 4 is 16. So last digit is 6. Square of 8 is 64. So last digit is 4. Square of 292. Square of 2 is 4. Last digit is 4. Square of 36. Square of 6 is 36. Last digit is 6. So we just need to do the square of the unit digit, and whatever the unit digit come in this, that becomes a unit digit of the total square number. So in this case, which has the last digit as 4. So you see the second and third option. What it means is 108 and 292. If you make a square of these two numbers, the last digit is going to come as 4. Okay, so third question is, given 125 square is 15625, then find the value of 126 square. So we don't need to do 126 into 126. What we need to do is we have to put everything in terms of 125 square, because if you look at the 5 options, the first term is 15625, which is 125 square. So we just need to break 126 in such a way that it's 125 plus 1, and then we need to solve that. So let's do that. As I said, let's break 126 as 125 plus 1. So we can write 126 square is equal to 125 plus 1 whole square. And then we'll solve this, and we'll solve this using a formula. So let's use the formula a plus b whole square. A plus b whole square is equal to a square plus b square plus 2ab. And using this formula, we are going to solve this bracket here, 125 plus 1 whole square. So let's start putting the value using the formula. So if you solve this, we'll get a square is 125 square, b square is 1 square, 2 into 125 plus 1. It's 125 square. It's already given, so we don't need to solve 125 square. Just put 15625. Then 1 square is 1 plus 251. See, in all these options, 15625 is already given. What it means is we don't need to touch this. We have to keep this as it is. We just need to solve this particular part. So when we solve this, we get 251. And if you start comparing with all these 5 options, you get 15625 plus 251. So answer is option number 4. Okay, let's take a look at the fourth question. Find the length of the side of a square whose area is 441 square. So let's solve this. So 441 is, because the area of a square is side square, so let's consider side as x, so area is x square. and area is already given 441. So 441 is x square. So now let's start solving this. Okay. So to solve this, we have to find the square root of 441. Okay. And we can use the estimation method because this number is little odd. So factorization method may not be very simple here. So let's use the estimation method. So when we do the estimation method, we see where this number falls. Okay. So we have to find the perfect square of those simple numbers, and then we have to compare that. So using the estimation method, we can see, we know the square of 20 is 400 and square of 25 is 625. What it means is the 441 is lying between 400 and 625. What it means is 441 is lying between 20 square and 25 square. This means the square root of 441 has to be between 20 and 25. What it means is it can be either 21, 22, 23 or 24. So now we have options available 21, 22, 23 and 24. Now we have to see which is the correct option. So square of 21, square of 22, square of 23 and square of 24 and compare with 441. So we don't need to find the square of all four numbers. We just need to use the method of square of unit digit. Okay. So square of unit digit of 21 is square of 1 is 1. And here answer is 441 here. So 1 is matching with 1. So 21 can be one of the options for sure. Let's try to say 22. Square of 2 is 4. The unit is 4. It's not matching here. So this is not the option. 22 is not the option. Square of 3 is 9. 9 is not matching with 1. So 23 is not an option. Square of 4 is 16. With unit digit at 6. 6 is not matching with 1. So this cannot be the option. What it means is the only option available here is 21. So the square root of 441 is going to be 21. Okay. So when we check the unit digit, we found 441 is a square of 21. What it means is the length of the side is 21 in that case, 21 meters. Okay, so next question is find the smallest square number that is divisible by each of the following number 4, 9 and 10. Okay, let's read one more time. It says find the smallest square number. Okay, so we have to find the square number. So let's change this question a little bit. Let's remove square from this question. So let's make this question is find the smallest number that is divisible by 4. That is divisible by each of these numbers 4, 9 and 10. So we have to, when we find the smallest number, the first step we do is LCM. And in this question, it has asked for the square. So that will become step 2. So in step 1, we'll find the LCM that will give the number which is divisible by 4, 9 and 10. And then step 2, we have to find what that number could be, which is a perfect square. Okay. And we'll solve this in by 2 ways. So let's solve one by one. The first option to solve this answer is, okay, so as I said, first we need to find the LCM. So if I find the LCM of 4, 9 and 10, that is 180. What it means is the 180 is divisible by 4, 9 and 10. But the question is we need to find the square number. Okay, let's check 180. 180 is not a perfect square. So we need to find what that perfect square number could be. So if 180 is divisible by 4, 9 and 10, what it means is all the multiples of 180 will be divisible by 4, 9 and 10. So let's start writing the multiple of 180 here. So if you start writing multiple of 180, it's 180, 360, 540, 720 and 900. We have to see which is the first number in this series, which is a perfect square, and 900 is a perfect square in this series, the first perfect square, which is square of 30. So what it means is 900 is the answer for this. So find the smallest square number which is divisible by 4, 9 and 10. So 900 is the answer. So this is one of the option to solve. Let me explain you what is the second option to solve this question. Okay, the other way to solve this question is the first step is common, find the LCM 4, 9 and 10. The LCM is 180. Now we need to factorize this. We need to factorize 180. So when we factorize 180, we get 5 into 4 into 9. And when we put in the square form, it's 5 raised to 1, 2 raised to 2, 3 raised to 2. So here if the 5 was a square, it was a perfect square. This number could have become the perfect square, right? So if you multiply this number with 5, this will become a perfect square number. So what it means is 180 needs to be multiplied by 5, this becomes 900. So when you factorize this, you need to come in the form where all these numbers are in the square form. And wherever we see the square form is missing, that is the number you need to multiply with. So in this case, if you multiply this 5, this becomes 5 square. What it means is 180 needs to be multiplied by 5. So 180 into 5, if you make multiply 5 on both sides, 180 into 5, which is 900, is equal to 5 square into 2 square into 3 square. So this is how you get 900 as an answer after multiplied by 5. So that's the other option, the other way to do the factorization method. Okay. So in the first option, what we did, we found the LCM, and then we did the multiple of 180 and see which is the perfect square in the series. And in option number 2, we see find the LCM, just factorize and see what number is required to make this a perfect square and multiply that number with 180. Okay, now question number 6. Find the smallest number by which 9408 must be multiplied to make that number as a perfect square. Okay, so in this case, 9408 is not the perfect square. There is some number which could be 2, 3, 4, 5, 6, 7, any number that needs to be multiplied with 9408. So the final number is a product of 9408 and that number becomes the perfect square. What it means is 9408 into x will give us some number, and that should be the perfect square, and we need to find that x. That's part number 1 of this question. And part number 2 is find the square root of that final number. Okay, so what is required here? We need to factorize the number 9408 and see what additional number needs to be multiplied to make that as a perfect square. So as I've said before, when you start factorizing, the best way is divide by a perfect square numbers, which is 4, 9, 16, 25, and 49. Okay, so let's factorize 9408. So I'm taking 16 from here to divide. So if you divide by 16, it becomes 16 into 528. So we have factorized 9408 as 16 into 588. Now the next step is factorize 588. So here I have taken divide by 4. So 16 remains as it is. And then 588 is 4 into 147. Okay, so now we have 16 into 4 into 147. The next step is factorize 147. So if you factorize 147, we get 3 into 49. So we have 16 into 4 into 3 into 49. If we want to simple keep in the power form, it's 16 into 4 is 64. 64 is 2 raised to 6, 3 as it is, and 49 is 7 square. So what it means is this number 2 raised to 6, 3 raised to 1, 7 square. So 3, the power of 3 is not the even number. So to make this even number, what it means is we need to make 3 square. So what it means is we need to multiply by 3. So if you multiply the whole number, which means 9408 by 3, this will become 2 raised to 6, 3 square and 6 square, and that will become a perfect square. So the answer to the first part of the question is find the smallest number by which 9408 must be multiplied so that the product becomes perfect square. So that answer is 3. So multiply the whole number with 3 and this will become 2 raised to 6, 3 square, 7 square. Okay, so the answer is 3 for the first part. Now let's try to look at the square root of the product. What it means is square root of the product means final number, which is 9408 into 3. So if you want to find square root of 9408 into 3, what it means is we already have 9408 into 3 as 2 raised to 6, 3 square, 7 square. So if you do the square root of 9408 into 3, what it means square root of 2 raised to 6, 3 square, and 7 square. The square root of 2 raised to 6 is 2 raised to 3, which is 8. Square root of 3 square is 3. Square root of 7 is 7. So 8 into 3 into 7. If you multiply this number, we get 168. So the answer of the second part of the question is 168. The square root of the product. Square root of the product 9408 into 3. So the answer is 168. Okay, so now the next question is how many numbers lie between the square of the following numbers? So So any number lying between 16 and 17 square, and any number lying between 99 square and the 100 square. We'll solve this, but there's an easy shortcut. Without even using pen and paper, you can find the answer for this, which I'll explain you. So answer for these is, when it is 16 and 17, you just need to add these two numbers, 16 plus 17, which is 33, and minus 1, 32. So answer is, for this, the answer is 32. Here you need to add 99 plus 100, which is 199, minus 1, which is 198. So answer is 198. Now let's see how to solve this on pen and paper. Okay, so to solve this, we'll use the formula a square minus b square is equal to a plus b into a minus b. So using that formula, 17 square minus 16 square is equal to 17 plus 16 into 17 minus 16, which is 33. And because we have to find the number in between, we have to reduce by 1, and then 33 minus 1 is 32. Similarly, 100 square minus 99 square, it comes 199, and then finally reduced by 1, which is 198. So as I said before, this is the formula we have to use. But if you are getting MCQ, you don't need to use pen and paper. You can directly add those two numbers and reduce by 1. So 16 plus 17 minus 1, 99 plus 100 minus 1. Okay, next question is question number 8. We have to fill the pattern. So let's see what the pattern is. We have 1 square plus 2 square plus 2 square is equal to 3 square. 2 square plus 3 square plus 6 square is equal to 7 square. 3 square plus 4 square plus 12 square is equal to 13 square. So let's see. The first two terms, 1 into 2 is 2, 2 into 3 is 6, 3 into 4 is 12. What it means is the third term is the multiplication of first two terms. Similarly, 4 into 5 is 20. So in this case, in the final one, if we say 9 into 10, answer is 90 here in this option. Okay, now let's look at what the right hand side of the equal to sign is. So the last term is 2, the right hand side value is 3, here 6 and 7, 12 and 13. What it means is, whatever we have the final term here, the right hand side number needs to be incremented by 1. So here we have 20. What it means is, here the answer is going to be 21. Here we found 9 into 10, 90. So here the answer will be 91. So here 21, here 90 and 91. Okay, so the last question of this figure it out section, question number 9, we need to find the tiny square given in the picture. That's part 1. And then we have to write the prime factorization number of the tiny squares. So tiny squares are these small squares in this image. So to find the tiny square, first we'll find how many big squares are there, and then we'll find how many tiny square in each big square, and then we'll multiply. So the first part is find the big squares. So let's start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 squares in a row, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 squares in the column. So the total number of big squares in this figure is 9 into 9, 81. Okay, so we have first part, we have 81 big squares. Now the question is how many tiny squares. So we have to find how many tiny squares in one square, one big square. So let's start counting. 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5. So 5 into 5, 25. So we have 25 tiny square in one big square. So now we can find the total number of squares, tiny squares in this diagram. So we have 9 into 9, 81 big square. One big square has 25 tiny square. So the 81 squares will have 81 into 25, which is 2025 tiny squares. So there are 2025 tiny squares in this picture. Okay, that's part 1. The second part is find the prime factorization of 2025. So when we find 2025 as a prime for prime factorization, we have to divide this number. So I've taken 25 to divide with, because 25 is a perfect square. So when we divide 2025 with 25, we get 81. And when we further split this, the 25 is 5 into 5 and 81 is 3 raised to 4. It's 3 into 3 into 3 into 3. So the prime factorization of 2025 is 5 into 5, 3 into 3 into 3 into 3. So this is how we can find the total number of tiny squares and the prime factorization of that number. Okay, so this is how we complete our figure it out section for the first figure out section. Now in next video, we'll look at the second figure out section, which is based on the cube and the cube rule. Thank you.